In this video, I want to talk about a little bit more complicated, a more advanced composition of two functions. So remember that the composition of functions is when we have one function and then whatever we put in, whatever we get out of that function, we just put it right into another function. And whatever comes out, that's the result. So in this case, we're going to find f of g of x and its domain. So the thing that we need to do is start as close to x as we can. So start with g of x. So g of x is the square root of x minus 2. And then we're going to do f to it. So f is negative 2 times the input squared minus 1. So this is f of g of x. Okay, so now we can go ahead and simplify that. So we have f of g of x is equal to, now the square root of something squared is just itself, so it should be negative 2 times x minus 2 minus 1. So this is going to be negative 2x plus 4 minus 1. So that's negative 2x plus 3. So you might be thinking, like, oh my gosh, we just made this problem so easy. This is just like a linear function, so the domain is going to be all real numbers. But unfortunately, if you're thinking that, it's not right. The thing is that we're still doing a composition of functions. So that means that we're still putting everything through the first function machine first, and then through the next function machine. And the deal is, we have to make both function machines work. We don't want to give any function machines any problems. Now, this function machine, the f function machine, it doesn't have any trouble because you can always square any input. So we shouldn't have any trouble with f. But when we put stuff into g is a function that can only take in positive or zero numbers, right? It cannot take in a negative number because it is it can't have a negative number under its square root, because if it does, it will be a negative, it'll be a complex number. So in the real numbers, we can't put in anything negative into this square root, which means that x minus 2 needs to be greater than or equal to 0. Now, that means that x needs to be greater than or equal to 2, so the domain is from 2 to infinity. And the thing is that we still have to put in x into g first. So we don't want to break the g machine, it will never get to f, right? So we can't break the g machine. So in order to make sure that we don't break the g machine, we still have to have this restriction on the domain. So the domain is now from 2 to infinity, even though it doesn't look like it should be from the simplified version of the equation. It still needs to be in order to make sure that we're not breaking the g machine. Because if you break the g machine, then you can't put anything into the f machine. So the other way that you can think about it is you can just think about the unsimplified version. So look for problems here when you're looking for your domain. So in my domain, I can see in the unsimplified version, okay, this is the square root of x minus 2. That's not going to be good if that's negative. So you can look in the beginning of the function, before you simplified it, to find problems with the domain. Don't look after you simplified it because you might break your g machine. You also need to look at the final function and see if there's any additional problems there. Now this one doesn't have any additional problems, but if you had like a 1 over x or something like that, then you might have an additional problem in this part of the function. We don't have that in this case. In this case, we just have the original problem, which was that x needed to be greater than or equal to 2. And so that's how you compose two functions that are a little bit more advanced And you have to make sure that you find the domain that works for the functions that won't break the G machine and won't break the F machine and won't break this machine either.